Okay, good morning. So, what I want to talk about today is I want to start to look at what's known as the shape of a distribution. So, the shape of distribution. And this shape of distribution can tell us an awful lot about the particular data set that we're looking at. So, if we have a look here, so what we're looking at are a couple of different histograms. So, just as a reminder, so if we think along the bottom on a histogram, so let's say when you're going from left to right, you normally have the value. So let's say, so this side will be the lower end of the value and this side will be the higher end of the value. And then from, let's say, from top to bottom, you have, so let's say this is your value. Okay, so it could be things like for example, height. And then from, let's say, from bottom to top, you're going the lower to higher. And this top to bottom is what's known as the frequency. So it's how often, let's say, a particular value shows up. Now, what we mean by the shape of the distribution, like if we have a look at the distribution here, we can see that they're all shaped in there's different shapes in relation to how the data is actually distributed. Now, something that I just want to kind of introduce as well is this idea of what's known as symmetry. So if I was to take something like, let's say we were to draw a circle, and I was to divide this, you were to draw a line, let's say right down the middle. So each side, let's say, would be what's known as symmetrical. And this line here is what's known as the axis of symmetry. So it's known as the axis of symmetry. So basically, like this would be symmetrical. So you have, let's say, each side. So you have the line dividing it in the middle, and then each side is the same. Now, when you look at histograms and we look at the distribution, we can have different types of shapes. So if we look at D, for example, so D is what's known as it's symmetrical. So it is. So you can see that there's the data on the left hand side is equal to the data on the right hand side. Sorry, it was not equal, but the shape is the same. So we have the same frequency on the left hand side as we have on the right hand side. So if we have a look at C, like what's happening with C is you're getting more data, you're getting more frequency of data showing up on the higher end of the scale and less on the lower end of the scale. If we look at B, which is what we're looking at here, so again, it's kind of all over the place. And then if we look at A, so again, there's kind of more data that's shown up on the lower end of the value scale than there is data showing up on the higher end. So this is what we mean by the shape of the data. Now, when you look at this, so let's say, so if you take, for example, so A, B, and C, for example, the data is what's known as skewed in some way. So so the data is skewed. It's not symmetrical. If we take D, for example, D is symmetrical. So D is symmetrical. There's symmetry there. So let's say one side of the data, they have the same shape. Whereas histogram A, histogram B, and histogram C, they're all skewed. So Another way to kind of think about it then is like we can actually put names on the different types of like what we expect to find in relation to the distribution of data. So we can say that one, and I'll just change the color on this. So one, we can say that data is symmetrically distributed. Symmetrically distributed. And if we take D, for example, D will be an example of symmetrically distributed data. So there's symmetry. There is symmetry in relation to the shape of the distribution. You can have data that has a positive skew. So it can have a positive skew. Now, if we think about data point A or the histogram A, this will be an example of a positive skew. So when you look at data like this, so see the way you have this shape, this end here is what's known as the tail. Now, when data is positively skewed, the tail tends to fall, let's say, on the higher end of the distribution, the tail. So let's say, so this here is what's known as the tail, and it falls on the higher end of the distribution. So that would be the shape of that data, it would be positively skewed. And then you can have the opposite then of that. You can have negatively skewed data. So negatively skewed. So if you take, for example, C here, so histogram C, so we can see that the tail, okay, it falls here. The tail tends to fall on the lower end. Most of the values will fall, or sorry, less, most of the values will fall on the higher end of the spectrum or the higher end of the value, but the tail will be towards the lower end, the lower value, let's say, on the histogram. So that's what's known as a negative skew. So this would be a negative skew, and then this one here is what's known as a positive skew. And that's what we mean when we're talking about the shape of data. That's what we're talking about. Like in relation to histograms, we're looking at what way does the data, what shape does it form? Is it symmetrical? Is it skewed? And these are the three types that we want to kind of look at in a little bit more detail. So again, when we mean symmetrical, again, this is what we're talking about here. So if we take D, for example, D will be considered symmetrical, and it has this symmetrical distribution, whereas all of the rest will be considered skewed data. And you can have a positive skew, you can have a negative skew, or you can have symmetrical data. So let's just start to look at each of these in a little bit more detail. So what we have here then, we have what's known as a positive, or sorry, we have symmetrical data. So this is what's known as a symmetrical distribution. Sorry, it should be. So this is what's known as symmetrical distribution. So we can see here, okay, so we have along the bottom, so again, so this is symmetrical. So again, if you were to think about, if you were to draw your line of axis, so if you were to draw a line of axis, let's say down the middle here, the data is going to be evenly distributed on either side. So it's what's known as symmetrical data. Another word that we can use to represent this as well is what's known as a normal distribution. So it's just a normal distribution. Now there are, like, if you look also as well, so what we have here, so also with symmetrical data, okay, or with a symmetrical distribution, the mean is going to be equal to the median, and it's going to be equal to the mode. So if you like, the central tendency is going to be along the middle here. So that's very important as well. So the mean, the median, and the mode are all going to be equal to each other. Now, so what are some examples of this? So if you're to think about like examples of data that would, when you plot it out on a distribution graph like this, or on a histogram, it'll give you a symmetrical distribution, or what's known as a normal distribution. So if you were to, let's say, so the height of people, so now this is the height of people. So if you were to take a population, let's say, so this is your population, and just randomly take a sample, the height of these people would follow a normal distribution. So if you think about it, let's say you might have, let's say, 5 foot. So that might be your middle value, and then it might go all the way up to 7 foot. Okay, and then it might go all the way down to, let's say, 3 foot, for example. Now, what's going to happen is with this, the majority of people are going to fall somewhere, like, let's say, so remember the frequency. So this is the frequency. So you have, this is high end and low end. So if you think about the majority of people, or the central tendency is going to be somewhere around the middle here. But then you'll also have like outliers. So you'll have, maybe you're not going to get people that are 3 foot, but for example, there's going to be less, if you're to look at the sample, there's going to be less of them that are going to be on this end, and there's also going to be less of them, let's say, on the very higher end, like let's say 7 foot. There might be some 7 foot people out there, but again, the frequency of that is going to be on the lower end. But basically what's going to happen is you're going to get a central value, and everything else is going to fall either side of that. So that would be an example of, like, let's say, data that would follow a symmetrical distribution. We're talking about the heights of people. And another one, again, the heights of people who are randomly picked. Like if you were to go and, let's say, to a basketball tournament and pick, like, measure the height of people at a basketball tournament, that data is going to be skewed, because generally people that pick basketball will favor taller people, and you're probably going to get more taller people, let's say, within that group, or within that population. So again, heights of people will be an example. Just randomly selected people will be an example of data that would follow a symmetrical distribution, or symmetrical shape. The other one then is like IQ. So IQ, or intelligence. What's known as intelligence quotient. Okay, or IQ. So again, if you were to go and randomly carry out an IQ test on people, what you'll find is that they will follow this normal, they'll follow a normal distribution like this. So generally you're going to get, let's say, average intelligent people, let's say the average intelligence will fall somewhere in the middle, and the majority of your population will fall somewhere there. You'll have people that will have low IQ, okay, they'll generally be a smaller group that will fall here, and then also then on the other side you're going to have a larger group, or a smaller group then, of people that are going to have really high IQ, but the majority of the population, let's say, will fall somewhere within the middle. So that's what we mean. So symmetrical data or the symmetrical shape, and generally that's what it will look like. And again, if we go back up to our histograms as well, so you have this here. So this is like this is what's known as a normal distribution or a symmetrical distribution. So what we have here then is what's known as a positive skew, or data that is positively skewed. So we have a positive skew. So again, with a positive skew, the tail, so again, so see this here, so this is what's the lower, let's say, side of the data, this is what's known as the tail. And the tail will generally tend to fall, it'll fall to the right, okay, or the higher end. So remember, this is the higher end of the values and this is the lower end of the values. So we can see that the tail here, so it falls to the right or to the higher end of the values. And what we can see is that with, like when you have a positive skew, most of your, let's say, data falls to the left hand side. So the most frequency of your data points is going to be falling on the left hand side, whereas the least is going to fall on the right hand side, and that's where the tail is, to the right hand side. So this data is not symmetrical, so it is unsymmetrical. Now if we think about, let's say, like if we think about the mode, the median and the mean, generally with this kind of data, what's going to happen is that the mean, the median, and the mode are generally not equal. So what's going to happen is that the mean is going to have the larger value, okay? And then that's going to be followed by the median, and then it's going to be followed by the mode. So if you see here, let's say on the graph, for example, we can see that the mean is generally going to be bigger than the median and the mode. So you'll get this kind of, the data will be skewed. So unlike with symmetrical data, where these are all equal to each other, generally with a positive skew, the mean, the median and the mode are going to be spread out. And generally the mean is going to have the larger value. So the mean is larger than the median, which is larger than the mode. Now, if we were to think about some real life examples then of this data, so you could say, so things like, so examples of, let's say, positive skew in real life. So if you're to think about things like, let's say, the number of children in a family. So what's going to happen is the majority is going to fall on the lower end. So you might say, let's say, so we could say something like 1, 2, 3, 4, 5, 6. Okay, so what you'll find is that, like, let's say maybe on average, depending on the population where you carry out the survey, the majority of the, let's say the most common frequency of the number of kids in a family might be 2, for example. So generally what will happen is, again, remember, the majority of your data is going to fall on the lower end of the scale. So for example, the number of children in the family will generally will be positively skewed. So if you're taking Ireland, for example, generally nowadays family sizes are smaller. You know, back years ago the family size would have been much larger. You could have 7 or 8 children in one family, whereas now they generally tend to be smaller. So again, for example, this would be an example of a positive skew in real life. And then you could also have, so some other ones. So let's say another one that they have is, let's say, so the age you learn to ride a bike. Okay, so generally, like that's going to start. That's going to maybe happen in the, when you're younger, on the lower end of, let's say, when of your age. So let's say, so the lower end. So you might learn how to. You're going to generally learn how to ride a bike when you're a kid. So again, if you were to go out and carry out a survey and plot that data and make a histogram, for example, what you'll find is that the majority of your people that you've surveyed, they will indicate that they learned how to ride a bike on the lower end, like when they were younger, basically. So again, that would be an example of positively skewed data. And another one might be the age at which people marry, for example. So again, that might also as well, it'll generally tend to fall towards, like when, let's say, like maybe on average nowadays it might be, I don't know, let's say 30 or 25, but it'll generally, if you're to take the whole lifespan of a person, it'll generally fall towards the lower end of the age. So again, these will be examples. So these are all examples of data that has a positively skewed distribution. So the next one then I want to look at then is what's known as the negative skew. So if we take something like this, so generally when you get this kind of distribution, this is what's known as a negative skew. So negative skew. So again, the data is not symmetrical, it's skewed in one way. So we can see again, like if we look here, the majority of the values are showing up on the higher end. So it's the opposite to a positive skew. So remember, like this would be the higher end of the values and this would be the lower end of the values. And we can see the data falls towards the higher end. The tail, so remember this is the tail. The tail falls towards the lower end of the values. You have a tail that kind of spreads off over to the left, and the majority of your data is shown up here on the right hand side towards the higher value. So again, it's the same, like if you were to look at the mean, the median and the mode, it's just the flip of the positive. So again, so the mean is going to be less than the median, which will be less than the mode. So we can see, generally the mean is going to fall somewhere around here, then followed by the median, and then followed by the mode. And like, the way to identify it is to look at where the tail is. The tail will generally be over to the left hand side. So again, if we were to think about some real life examples then of data that would be negatively skewed. So we can think about, like for example, so the age a person gets. So imagine like we were to look at the age, so generally this might be the higher end of the age. Let's say when a person is older, generally what you'll find is that people, as you get older, your eyesight, your near sight eyesight generally tends to deteriorate. So generally what happens is at an older age, you're going to need reading glasses, for example. So, it's going to fall up. The majority of people who need reading glasses, if you're to look at the age as the value, generally that it's going to fall up here on the higher end of the scale. Another one would be if you were to look at, so for example, the height of basketball players. So again, the height of basketball players, the majority of the players are generally, if you're to look at height, let's say, they're all going to fall. They're going to fall on the higher end. They're all going to be tall, basically. Okay, so if you were to look at like the frequency at which you find tall people in a basketball team, it's going to be quite high. So it's going to fall somewhere up here like that. So that's what we mean. So they're just like, so let's just have a look. Let's just go back over what we've done. So we're looking at the shape of the distribution. We can have different shapes like so. Okay, so you can have what's known as a normal distribution, which is this. And then you can have so it's known as the symmetrical distribution. Then you can have, it can be, data can be positively skewed or it can be negatively skewed. When the data is symmetrical, you generally get your axis of symmetry, it falls down the middle, and the data is evenly distributed on either side of that symmetry. If you, so with it, when you take symmetrical data, generally the mean is going to be equal to the mode. The mean and the median and the mode are all going to be equal to each other. So some examples of symmetrical data in real life would be the heights of people just randomly selected. And if you carry out an IQ test as well, what you'll find is that the results will follow a normal distribution. Then you can have data that has a positive skew. So again, with data that has a positive skew, you look for the tail. The tail is generally on the right hand side, and the majority of your data points are going to show up on the left hand side on the lower end of the scale. So some examples of this in real life would be the number of children in a family. Okay, they'll generally, if you're to think about the number of children that would be in a family, it's generally on the lower end of the scale, maybe 2 or 3 children. The age you learn to ride a bicycle, generally, if you're to look at your age, you're going to learn how to ride a bicycle when you're younger. So again, this will, if you were to go out and survey, let's say, a population, what you'll find is that the data will be positively skewed. And the age at which people marry as well is another example. And then the last one then is the negative skew. So again, this is just the reverse of a positive skew. What you'll find is that the tail will be on the left hand side and the majority of your data will fall on the higher end of the scale. Generally the mean is going to be less than the median, which is less than the mode. And like real life examples of this would be the age a person gets reading glasses. So for example, a person generally tends to get reading glasses when they're older. So again, their data is going to fall somewhere along here. And the height of basketball players. So generally, if you take the height of basketball players, they're all going to fall on the higher end of the height scale. They're all going to be taller, so they are. So that's what I mean. So we've just started to look at the shape of the distribution, and I hope that makes sense. Okay, so guys, thank you for listening.